Today I will discuss about a very common subject in hydrology known as routing. First of all, what is routing? Routing is a technique by which you can predict the change in the shape of a hydrograph from a specific point or from a starting point to a ending point. So, if I explain it a little bit more, water flows through river, canals in different. It flows also through the pipelines, open channel pipelines, drains. Now, what happens is, due to the shape, size, surface roughness of the channel, and different other factors, when a rainfall occurs in this place, suppose in place A, so when a rainfall occurs, then there will be a specific hydrograph which represents the flow of water through this A point. But due to the shape and size of the channel roughness and all these factors that I just discussed, this shape of hydrograph changes in the downstream. Suppose if I want to see what is the shape of hydrograph in this point B, so due to the change in shape and all these factors, the shape of the hydrograph will change with respect to the shape of this hydrograph, the hydrograph at point A, the upstream. And the technique which helps us to predict the shape of hydrograph at B with the help of the data from point A or data of the hydrograph of at point A, this technique is known as routing. So if you check this simple flow chart describing the routing, you see I have said that this routing is a technique to predict the changes in shape of a hydrograph as water moves through a river channel or also through the reservoir. Because when water is stored in this reservoir, now the water at this point, in this point, the hydrograph at this point A will change once the gate of this reservoir opens. Because a lot of head, this potential head will convert into kinetic head, and there will be a change in shape of the hydrograph at point B. So it can be like this or like that, whatever may be the case, the shape will change. Now if you try to predict this one with the help of this one, or the data of this one, you are routing or you are using the technique known as routing. This routing can be applied in channel, which is known as channel routing. If you try to predict this hydrograph with the help of this hydrograph. So this is a river channel, water is flowing through a channel. Then you are using the channel routing technique. When you are trying to predict B with the help of A, when water is flowing through a reservoir, okay, this is known as reservoir routing. So routing can be of different types. Now you can also predict, suppose suddenly a spot of rainfall occurs in a very small channel, which are popularly known as chhara, right? Or you can also say it as canal. A very short, very small channel of river. And generally this is observed in the hilly regions. Most of the year the riverbed is dry. You can walk through that riverbed. Suddenly in the monsoon time, in the upstream, a huge storm occurs, rainfall occurs, and this is a very extreme rainfall, suppose not like common rainfall. And what happens is a lot of amount of water has suddenly come into this point. So it will, as is the property of water, it will come down to this point B. So when a large volume of water suddenly come and inundate some points in the downstream, the channel in the downstream may not be ready with that volume of water due to the siltation during the non-monsoon period. So the channel depth decreases. As you know, more you go downstream, the depth of channel decreases. So what happens is that sudden volume of water inundates the downstream channel, and as there is not enough space to accommodate that extra volume of water, what happened is this extra volume of water overflows and it floods the adjacent catchment. So when you try to predict the hydrograph of such cases at the downstream with the help of the data of this point A upstream where the extreme rainfall has taken place, this type of routing is known as flood routing, because this type of that type of storm, that extreme storm will definitely cause a flood if that extra volume of water cannot be accommodated by the channel downstream. So you have channel routing, you have reservoir routing, you have flood routing, and you can see I have explained here also. So just read this line. Routing can be used to determine whether the pulse of rain reaches this city as a deluge or a trickle. Okay, that is what routing is. How the water behaves in the downstream after the rainfall occurs in the upstream. Now, this routing can be divided into two parts. Technically, this classification of routing, flood routing, is based on the geographical properties. But now what I am saying is based on the technique used. So there is hydrologic routing, there is hydraulic routing. Now in case of hydrologic routing, it is actually a lumped routing. And sometimes semi-distributed, but mainly lumped routing. So what it does is, in this lumped routing, they try to solve the continuity equation. And for this, what it does is, it uses linear and non-linear Muskingum models, or optimize the parameters of one-dimensional conservation of mass and storage equation. Mainly they solve the continuity equation. In one type of routing, you use the linear and non-linear Muskingum models to solve this continuity equation. And in another case, you can also optimize or estimate the parameters of the conservation of mass and storage equations. And how they estimate it? They estimate it with the help of the upstream data as well as downstream data, because first they have to calibrate. Then only they can use the model to predict. And during this calibration, they actually estimate the parameters of the equations. So estimation parameters of the equation means, take the example of the equation which is used for representing straight line, y is equal to mx plus c. Here y is the output variable, x is the input variable. But m and c is actually the slope and intercept, both of which are parameters. And for a known value of y and x, we generally first estimate what is m, what is c. And then what we do is, we try to find the output of some inputs, of which the output is unknown. Now how we estimate the output which is unknown? Because the parameters m and c is already known. So at the time of calibration, we try to estimate the values of m and c with the known data, where both x and y is known to us. So here, suppose this is x is your rainfall and y is your runoff. Then for a certain catchment, if I know rainfall and runoff both, then I can put in this x and y in the equation y is equal to mx plus c. I can find out m and c. Now I can use the known value of m and c to predict y for a rainfall whose runoff I do not know. So here also, in this case, we use either linear and non-linear Muskingum models to find the parameters of the equation, continuity equation. And then what we do, then when we know the parameters of the continuity equation, we try to predict the unknown. Now in case of this conservation of mass and storage equation, we can also optimize the equation. Either you use linear and nonlinear masking models or you use optimization technique. And in this case, you can use any type of optimization technique. But you know that this is a lumped routing, not the distributed routing. So accuracy of hydrologic routing is not very satisfactory compared to that of hydraulic routing. Now in case of hydraulic routing, as I said, distributed routing, we use partial differential equation of unsteady open channel flow. Either you use Saint-Venant equation or you use dynamic wave equation. You can use both type of partial differential equation and solve it to find the unknown. So this is the major division of routing. Geographically, a routing can be differentiated into channel, reservoir, flood routing. And technically, you can use divide this routing into hydrologic and hydraulic routing. And in case of hydrologic, it is lumped, so accuracy is low. Sometimes it is also semi-distributed, but it is not accurate as hydraulic routing, where distributed routing is taking place. And in the distributed routing case, we solve the partial differential equation representing unsteady open channel flow. Whether it is Saint-Venant equation or this dynamic wave equation, it is up to you. In case of hydrologic routing, we solve the continuity equation. And there we either use linear and nonlinear masking models, or we optimize the parameters and estimate it. Parameters of what? Conservation of mass and storage equations. And all this parameter estimation is done with the help of the hydrologic data available for both upstream as well as downstream. Because you have to have the downstream data, otherwise you cannot calibrate. And in case of calibration, what happens in the calibration phase? We estimate the parameters. And in the prediction phase, with the help of that estimated parameters, we try to predict the unknown output for the input. So this is the brief introduction of routing. Now I will publish series of lectures on routing. So my first lecture will be about, first few lectures will be about hydrologic routing. When hydrologic routing finishes, I will go to the hydraulic routing. So remember to subscribe my channel if you have an interest to learn about routing and its technique, because it is still one of the most significant concept if you want to learn hydrology. And not only learn, if you want to apply the concepts of hydrology. And also, these routing questions are very favorite of these GATE examiners. Most of the time, this type of questions come in GATE exams and other competitive exams. So, this can be a good addition to your database of courses. So, subscribe, and whenever I post another thing about routing, you will get updated. Thank you and goodbye.